Hello, welcome to part 2 of a 4-part series on electronic still photography, coming to you from Rochester Institute of Technology. Last week we talked about electronic cameras, how they work, and who uses them. Today we'll discuss and demonstrate how you can use scanners to get photographs into your personal computer. Follow along with your program notes as we go. At around 2 o'clock today, Eastern Daylight Time, we'll take a break so we can all take a stretch. And during the last 15 minutes, we'll answer your phone and fax questions. Write down your questions on the call-in question form throughout the program and be ready to call in as soon as the phone lines are open. The toll-free number is, for calling questions, 1-800-262-3144. 1-800-262-3144. The fax number, area code 716-724-5522. If you can't get through, try again. I'd like now to introduce you to the people that are going to be involved with our show. Over on my right today, I'm really pleased to have with me Jeff Schufelt, who's a student in the School of Printing at RIT. He'll be working on one of our scanners on the other side of the room. Also, with us on the set today is Paul Melnichuk from Eastman Kodak Company, and he'll be here to talk to us about photo CD. And last but not least is our floor manager, Tony Girardi. Now, Tony has been recently promoted to head or chief floor manager, so he'll be working with us for the balance of the day. Okay, let's get started. Last week we started here, so we're going to come right back to where we began last week. We dealt almost exclusively last week with electronic cameras, capturing devices, still video, still digital cameras, and then moving them into the personal computer environment. Let's open up our idea about what electronic photography is, and now move away from photography in terms of electronic cameras, moving over to scanners, film scanners, flatbed scanners, drum scanners, and even hand scanners. So that's where we're going to be starting today. Now, the question is, who uses scanners today? Lots of different people. Printers, for one. Printers have probably been using scanners longer than just about anyone out there because that is part of their trade. They have the most experience. Photographers are also starting to use scanners. They have been using them primarily as a comping tool or as a tool to look at their images or possibly in some business practices. Artists are also using scanners, possibly as part of the creative process to bring in images and use them to model additional images from that. And business imaging as well. A very large growing area of the market right now is having the ability to bring images and put them into your documents. How do you get them in there? Desktop scanners, photo CD, and electronic cameras. Newsrooms, scanners have been part of what they do for some time, but now it's coming down to the desktop. They are using desktop scanners to bring in their images to use in newspapers and in certain cases magazines. Photographic studios and art studios are using them not necessarily in the production process, but in the creative process. Medical facilities as well, having the need to bring in the photograph from a surgical procedure or some other training material necessary for a doctor. A scanner is a fast, easy way to bring an image in and use it as a training tool. Service bureaus as well. We're going to try to give you an idea, as I think probably a lot of you in the audience are unclear on what a service bureau is. It's just that. It provides a service to the imaging community. They also provide scans. Photo labs have been using scanners for some time, not so much for image restoration and retouching, but actually in their quality control work. Okay, looking at different applications of scanners. Okay, we have these devices, these boxes. What do we do with them? Well, we can scan in photographs. We may have an image that we want to scan in, for instance, wanting to move that into a personal computer to do restoration or some kind of creative work. These are two of our younger faculty members at RIT. Okay. Also the possibility of image montage. The photographer in many cases may want to combine their work in front of the camera to create an assortment of things. Why not do that on a desktop scanner? The idea of scanographs. What is a scanograph? Well, it's sort of a made-up term. using a scanner to make images of three-dimensional photographs. We'll show you a tape in a few minutes that describes that in more detail. Halftones and color separations, as I've already mentioned, printers use these on a daily basis and in certain cases around the clock. Drawings, a photographer, an artist, an art director, someone who's in the creative field or in the technical field may want to take a drawing, put it on a flatbed scanner, some other device, bring it into the computer to do further image processing. Also text, having the ability to take my scribbled notes here, as you see, putting them on a flatbed scanner, and then using optical character recognition software, we can move this right over into a desktop publishing environment. Okay, now, first of all, I'd like to show you, as I mentioned just a second ago, a scanography demo. So let's take a look at this tape coming up with Pam Frederick from RIT. Pam Frederick. Pam, where do you find your objects?
Beaches, outdoors, junkyards, garbage, places like the Brooklyn Union Wrecking Company.
Nothing sacred, right?
Nothing sacred.
Okay. Pam, for a while now, you've been making pictures on a scanner. Why do you decide to use a scanner and not use a camera? What's the point?
Well, I used a scanner because it was there, because it was fun, because it was different, and it afforded a different kind of tool to explore.
Let's take a look at some of the pictures that you've printed out. Now, this is a picture that you made using a scanner connected to a Macintosh, an inkjet print.
Yeah.
Okay, all right. What is it from a visual standpoint that excites you about this kind of technology?
Oh, it affords the opportunity to get totally unexpected results. I thought this would be harder.
You said unexpected. What is it unexpected? It sounds like there's a certain degree of surprise that you're looking for. You're not interested in predictability, but you're interested in surprise.
Oh, absolutely. I mean, if you look at a computer, it's a box, you know, and it's a cold-looking piece of plastic, and yet something this soft and this appealing can come through the computer with the use of the scanner and the use of the different printers. That surprised me.
We're talking about different kinds of scanners. There are a number of different types. They serve different purposes. Let's go over some of them right now. First of all, if we think of the video frame grabber or digitizer, this is a form of scanning device. It's the lowest form in terms of resolution in capturing images today. Moving up the scale to much higher resolution are flatbed scanners. Flatbed scanners like the one I showed you earlier today. Back in this side of the room, you'll notice that this case we have the ability to put in prints and then scan them. Now this would be primarily for two-dimensional scanning, color, grayscale, or line art, or as you've just seen in that demonstration, making scanographs. The hand scanner, well, we can put a scanner in your hand today as well. If you take a look at this little device, it's a rather curious thing that you could take an image and scan it with the hand scanner. It's used primarily, for optical character recognition, but you could also scan line art with it and other things as well. You could even scan body parts if you wanted to. Okay. Film scanners as well. Having the need to scan in 35mm films or transparencies is really a very important part of scanner operations today, especially for newspapers, magazines, and others that are involved with desktop publishing. Slide scanners as well. And when we think about a slide scanner is really what had started the desktop revolution in the mid-1980s. Cameras are also a form of scanning technology. Last week we talked about digital cameras. This is a silver halide front camera here that's usually used for recording film, but what we've attached to it is a scan back. This is an area array as opposed to a linear array that we discussed last week and we'll discuss a little more this week as well. This comes either as a CCD device, meaning a charge coupled device, silicon, light sensitive, or a tube device, usually a Vidicon tube. Drum scanners as well. Now these are not CCD devices, they work on photomultiplier tubes. And at this point, we're going to be showing you some drum scanning technology in just a few moments. Okay, before we do that, I'd like to talk to you about a very important area called reverse engineering. So if we go over to the overheads for a second, let's take a look at this illustration that I have here. Most photographers place themselves in this area, possibly a designer using a camera. We then here have the scanner, we have the computer, and the hard copy output. In many cases, photographers only think about this area. They're not really involved with scanners at all, and the computers they're starting to get involved with. The hard copy output, they generally think about the continuous tone print, the reflective print that they would use in a display or their portfolio. We have to also think about the halftone image, and what photographers, artists, and printers need to do is learn how to coordinate and communicate between these different areas. This is especially important with electronic imaging because the job doesn't stop at the camera. It only begins at the camera. All right, let's be a little more detailed now and talk more about the specifics of reverse engineering. What is your output? Is it a halftone image? Is it a continuous tone image? You have to know. Sometimes it's going to be both. The monitor calibration. Calibration means we are trying to set up that monitor to the original conditions as well as the hard copy output. Is the monitor that Jeff and myself and Paul Melnichuk working on today calibrated? Well, it should be if it isn't. To those two different areas, especially towards output. Ambient lighting. The ambient lighting is the lighting that's around us while we're working at a computer and how we're addressed. That affects how we look at images and make decisions. Printer defaults. Our printing devices, which we'll be talking about a lot more in the next few weeks, like XL 7700 printing, XL 7720, or laser printing, or some other kind of electronic printing process, requires that we know where the defaults are on this and how we can work with them. The image size is important too. This has not been a real critical issue for photographers in the past, but it is in today's world of electronic imaging. The highlights need to be set properly. The gray balance, in other words, the balance of red, green, and blue, or cyan, magenta, yellow, and black, have to give you an even balance in the image. The shadow placement must be done properly as well. And image enhancement. What does a photographer or artist do to improve, or in certain cases, actually hurt the image? This can happen. We may not be aware of it while we're working on the personal computer, but we have to be involved with it in the engineering process. This is a creative and technical engineering process. Image retouching. What you see on the screen may not result with what you're seeing on the hard copy output. The gamma, or in other words, the contrast section of the middle grays. How is that set based on your reproduction needs? The imaging software that you work with. Does it give you the control that you need to work discreetly with highlights, middle tones, and shadows? It must today. And not only must it give you that control, you must know how to use it. Scanner resolution. It's simply not good enough to just place a film in a scanner or a print on a scanner, get a scan, and then just take whatever the scanner gives you. You must have the scanner resolution set for output devices. What type of scanner are you using? Some scanners work very well for certain types of work, transparencies, films, some don't. You need to discover that for your type of photography. The lighting design. Let's get back to the photographer right now. How does the photographer light? In the studio. On location, that's obviously many times not an option. But in the studio, they must have some idea of how this is set up and how they can then establish their highlights and shadows for reproduction. And the lighting type that's used, the color temperature, the specularity, or the broadness of the lighting as well. And of course, most important to the photographer is the camera selected, the lens, and the subject. And may I include in there the film selected as well, the choice of film. Okay, I'd like to start talking now about scanners by first rolling in with a scanner demonstration that we've done at RIT. So here's a short tape on some scanners at RIT. We're at RIT's Electronic Photography Lab. This is on our main campus now. and I'd like to show you a few things that we do with 35mm scanners. At this point, I'm going to be focusing on the Nikon 35mm scanner, which is essentially designed to scan 35mm transparencies, color negatives, and black and white negatives. Okay. I'm already launched into Adobe's Photoshop. So looking at the computer now, we have Photoshop in place, Nikon scanner. Over here we have a 44 megabyte removable drive and another still video input device from Canon. I'm now going to launch the Nikon scanner driver, which is under a Photoshop acquire function. Now I have no film in the scanner at this point. There's nothing there whatsoever. While we're waiting for that, let's turn on the light box, and I have some transparencies and color negatives that I want to work with. In this case, I'm first going to take a 35mm black and white negative. There is a special film holder for this, and I'm going to load it right in the film holder, much the way you would in a film carrier in the traditional darkroom. Once I have the film loaded in here, the next thing I would do is take a cleaning device. Some people use anti-static cloths. Some folks use the Camel hair brush, the same as you would in a traditional darkroom. In this case, I'm also going to use a little dust off as well, and hope that I don't blow the film right out of the holder here. Okay, I'm now loading the scanner. Now, when I load the scanner, let me first of all show you the size of it. Physically, it's about the size of two shoe boxes next to one another. And when I load the gate, I have to make sure that the film is in the right position so it can scan back and forth. It's a very simple procedure. Now, I have the film loaded. I can see the power is on, the scanner is not busy, and I'm going to go in and make my first scan. After I open up the Nikon driver, I get a lot of very significant information here. First of all, I am set for a black and white negative, and I have here the size of the scan in terms of inches. Now that can be switched to pixels or millimeters or inches. Most of the time we deal in inches in the photography and printing world. And I also have the pixels per inch as well as the scan pitch. Now this scanner driver automates many of rather difficult procedures of the late 1980s. So we can go in and select our resolution, let's say at 100 pixels per inch, and we can go to pitch 4, which would give us roughly an 800 kilobyte file. So let's go ahead and do a preview of the image. The reason I'm doing this is, first of all, I must determine if any cropping is necessary. Also, I have to see if the image is in the right position. Is it upside down? Is it inverted? Is it turned on its side? As you can see right now, it is in the right position, down in the lower section of our screen. Although this is my larger image area, and I don't need to scan this larger white area out here. So I'm going to crop down to the image area. Now most photographers like to crop within the camera. So I'm going to scan the entire image. I'm also going to go in and take a look at my highlights, which seem to be around a brightness value of 230. And I'm going to check my shadows, which seem to be around the brightness level of 15 to 20. This is ideal for reproducing this photograph under these brightness conditions, or exposure conditions as the photographer would call it. I would also have the ability to adjust the image if it was in the wrong position without taking the film out of the holder. As you can see right now, I've inverted it. If I had put it in upside down or reversed, wrong reading, I could flip it. If it was upside down, I could turn it in this position as well. Now, for this particular photograph, I want to try to keep my file size at under 1 megabyte of information. This would be about as low a resolution that you would use in most circumstances for video playback or low-end publishing. I would have the ability also to adjust exposure, brightness, in other words, contrast, and if I had a color film in there, adjust the color. I can also adjust the brightness of the image automatically and the gamma of the image automatically. Also the focus. But take it from me, in most cases, the default works very, very well, and then you can make minor adjustments where necessary. Now that I've made the crop, I've checked my highlights, I've checked my shadows, I'm ready to do the scan. Now the scanning process takes a little longer than the preview process, but now we're bringing in the high resolution file. The typical scroll bar is coming up, and now my image comes directly into the window, and I'm ready to start editing. What I'm showing you now is another form of scanning transparencies. This is a slide scanner. This is an iconic scanner that has 3,000 dots per inch resolution. What we're also looking at here is the power supply device for this scanner. Here's the optics, the illumination source, and the scanning takes place back here in this section of the machine. We're connected to a Macintosh 2 computer, and I'm using Adobe Photoshop as we did before. Before we start scanning, we select a transparency, and like any traditional darkroom situation, we clean off the film, remove the unwanted dust, and then mount that in the transparency. Once the transparency is mounted in the scanner, I then have launched Adobe's Photoshop, and I go out and search for that scanner through the File menu, and then acquire it through the plug-in Iconics 1400 series. Now this scanner is only for transparencies. It can't work with color negatives. First of all, I would do a preview. This again gives us a very low resolution grayscale file, so the photographer can do some cropping, make sure in fact that he or she has the right film in there in the first place, and it rolls in very quickly on the Macintosh computer screen. Once we have that film into the computer as a low resolution file, so as I come in and do my crop, photographers like to crop as close to the full frame as possible, switch it to RGB color, and then all I do is go ahead and make my scan by hitting OK. And the scanner does the rest of the work from here on out. Okay, Jeff Schufelt from RIT. Jeff, you're working with the drum scanner setup today.
Yes.
And maybe you can give us an overview of what we're looking at on the total desktop here.
Well, what I have here is a Macintosh Quadra 950 with 8 megabytes of RAM and a 500 megabyte internal hard drive. It's connected by SCSI to the Howtech D4000 drum scanner. This scanner allows me to scan a resolution up to 4,000 dots per inch, and I can scan both reflective or transparencies, and they can be negatives also.
Okay, this is a different technology now. CCD technology, what we talked about before. Here, PMT technology, which I mentioned before. So we're actually using a tube technology here.
Correct.
To do the reading, the line reading. Okay, can you give us a little overview on the scanner and what we're looking at?
Sure. What we have here, we're going to be scanning, today I have two 4x5s and a black and white negative that I've set up today to scan. And the way this would work is the light source is going to pass through. It's going to go through a beam splitter through the 3 PMTs for the RGB signal, which changes that into a voltage. Then later on that's converted to a digital signal that go back to my Macintosh.
Now that's going back via SCSI cable.
Via the SCSI bus.
And some people asked last week, what's SCSI? Small Computer System Interface.
Correct.
And that's the cables that we're seeing up here, actually in the back of these devices, which we wouldn't normally see. Okay, now the drum, you've taped those on and you're placing it into the scanner, right? What else do you have to do to the scanner after you put the drum in there?
Nothing. It's just all I set it up, put it online, and shut the door, and I'm ready to scan from my Macintosh.
All right.
I just check to make sure the drum's in there tight.
Right.
Put the scanner back online,
Okay.
and now I'm ready to go.
And it closes that case to cut the ambient lighting, I guess.
Correct.
I would think, yes.
The way we're going to scan today, I have multiple ways to scan. I can scan through a Photoshop plugin, or I can scan through more of a higher-end package using pre-press technology, SpectraScan or multi-scan.
Okay, so you have a plug-in device with Photoshop,
Yes.
but then you could also use a standalone piece of software like pre-press technologies to do special scanning operations that would do what? Enable you to do...
That allows me to scan negatives, and plus it also allows me, gives me a little more controls. I can remove color cast. It has a built-in densitometer, so I can make color corrections to an image. Say if I
Right.
have a cyan cast, I
Gotcha.
can remove that cyan cast.
That's good, because I wanted to make that clearer with people later on during the teleconferences that standalone software in certain cases enables you even further than plug-in software.
Probably more towards your printer color separators will be using more of the higher end package. Because
Gotcha.
they need more of those controls to set up to go to press.
All right. So you're...
Going to launch Adobe Photoshop.
Okay. At this point, we're done with the scanner,
Correct.
essentially. Everything is mounted. Is it really important how you get those films onto the drum?
Yes, you don't want to have any bubbles in them or any wrinkles in them. You have to keep your drum really clean because it's going
Right.
to pick up all that dust in your scans.
Right. Some photographers are surprised that with certain films, you mount them in oil.
Yes, that usually makes your photographer very nervous, but it's usually just general mineral oil. It's not going to hurt your negative
Right.
or your chrome. The only reason we use that is for if you're scanning a 35 millimeter enlarging over 400%, or you have a lot of scratches in your emulsion. This way the oil will fill in those scratches, and this way it won't show up when you make your scan.
Great. So they shouldn't worry.
And plus it does away with Newton rings when you're
Okay.
enlarging. So I just acquired a Howtech plugin.
All right. Now that doesn't come with Photoshop, right?
No, it doesn't. It comes with the scanner itself.
All right. All right. Can you explain the window we're looking at right
Sure.
now?
We have here in this window, we have the scanner, which we only have one scanner here, which would be the Howtech D4000.
Mm-hmm.
I'll start off scanning the two color 4x5s that I have, so I'll be on color mode. I have an aperture set in here. I can manually go in and set my aperture, like in a traditional high-end way. The scanner operator would have a chart, and he'd look at that chart and see how large he's going to make his image, then he'd pick that aperture. But here the software would do it automatically for you.
Mm-hmm. Mm-hmm.
I can set my resolution from 32 all the way up to 4000 dpi.
That's a lot of information.
Yes.
A lot of information.
You'd only be scanning at 4000 if you're doing a 35 millimeter neg, and you're larging out to a high-end film recorder, very high quality work.
Okay.
Sharpness scale, this ranges from -10 to +10. -10 would dull the image. The higher the number would be, it sharpen the image more.
Okay.
This is more of a touchy-feely type thing. It's something you really have to get used to. Threshold is working in brightness levels. And the gamma setting, as you mentioned earlier, is going to change the contrast of my image.
Mm-hmm.
And I have auto color range here.
Right.
I'm going to be on channel 3 because I'm doing an RGB image.
Right.
And what this will allow me to do, automatically will go in and set my white point and my black point, working on a 12-bit scale. So I'm working from 0 to 4096 brightness levels.
That's pretty important.
Yes.
Okay.
I can manually go in and set this. I can turn this off, then I can manually go set those numbers. But I'm used to working on an 8-bit scale, not a 12-bit scale, so I'm going to let the technology do the work for me.
Okay.
Image type, transparency. Have an autofocus mode. I can focus it from the scanner if I care to, but the technology is very great, so I'm just going to allow the technology to do the work for me.
Wait a minute. What's that allow backgrounding mean?
What this will allow me to do, as I'm scanning in the background, I can go back to Photoshop. Say if I had another image in Photoshop, I can continue working on that image while my scan is being processed.
That would slow the process down, though, I
Yes,
think.
you'd have to have a lot of RAM.
We
in
won't
here.
do that.
No.
We don't have enough time today. Okay.
So I'm just going to select a large area of my drum and do a pre-scan.
A lot of photographers and artists ask me, they say, what difference, if you set the right resolution, what difference does it make if you do the pre-scan? I think the pre-scan is probably one of the most important parts of the entire process in any scanning, correct?
Correct. What I'm setting up on the pre-scan is it's giving me a low-res black and white image. And this way I'm allowing to crop down to that image. So if I was to crop this image wrong, what it's going to do is set up on a brightness level off the drum itself. So my white point is going to be really skewed that way.
Very important
So-
tool. It's actually a time saver when you look at it.
Yes.
Now we see the films coming in. Actually, some transparencies here. And wasn't there a black and white negative on there too?
Yes, the black and white negative the only way I can scan negatives off this scanner is using pre-press technology software.
Okay,
so I'll
so
have
you
to
did
scan
that.
that later.
All right, well, I'll tell you what, I'll give you a chance to do that when I go to the other side.
Great.
All right. So now you're able to do what?
Now what I'm going to do is crop down to an image.
Mm-hmm. Okay, just grab onto those handles.
Just grab onto this image. Now I have this image cropped.
So you're going to scan that while I go over and show some of the other things that we're doing here. Go ahead, do the scan. We'll come back and take a look at the results in a few minutes.
Okay,
it's
great.
almost like we're waiting for something to come out of the oven here. Oh wait, don't you have to say hi to somebody out in the West Coast?
Hey, I'd like to say hi to Amy out at Cal Poly from Paul Pelletier.
There you go. All right. All right. I wanted to talk to you now about scanner sensors and how we are actually working and acquiring this information. There are basically two types of scanner sensors that we will be working with. First of all, a charge-coupled device. This is light-sensitive silicon. This is what we would have in our desktop scanners, for instance, our film scanners and our flatbed scanners. Not what we just saw Jeff working with. Also, we have the photomultiplier tube scanning device. The photomultiplier tube scanning device is going to be used in PMT scanners like your high-end color separator scanners and those that we've just seen on the other side of the room, a desktop PMT. Okay? I would like to show you this on terms of a graphic. So if we go over here, and you're now looking at the graphic that I have, on a film scanner, we have a light source, the lamp. This is going to be either a tungsten, a fluorescent, or even a strobe source, as we will see in some of our other scanners today. And then we either use an area or linear array. This is a charge-coupled device with discrete, fixed resolution in terms of spatial information. Then it's connected via a GPIB or SCSI connection. This stands for General Purpose Interface Board. Some of the scanners are spec'd that way. Some are spec'd for small computer system interface. Both interfaces have advantages, and sometimes you have the option with the scanner of going one or the other. In fact, I think Jeffrey could do that with the Haltech scanner as well. Okay. Your flatbed scanner is also using a CCD device, usually a linear or trilinear device, meaning we are using one row of CCDs or up to 3 rows of CCDs for one pass color. So we had red, green, and blue on one pass. In certain situations, scanner companies will produce for you a lamp, either fluorescent or tungsten, that comes over the flatbeds so you can do transparencies as well as doing flat art. Again, the GPIB SCSI interface. Your PMT scanners, like we just saw Jeff work on, the same kind of connection, except we have a photomultiplier tube. We might have 1, 2, or 4 tubes. Some scanners do the work in terms of separating color by using prisms. Some have separate PMTs, and some have a separate PMT, photomultiplier tube, for doing your sharpening, unsharp masking done optically. The images are put on a drum, a lamp is used for transillumination or reflected copy, and we transfer over. Let's go back to the scanners now, and I wanted to show you some of the scanning technology we're using on this side of the room today. First of all, I might opt to do a flatbed scanner. Now, working with a flatbed scan, if I was looking at, for instance, an older photograph that needed some restoration or a continuous tone photograph, either can be done here. Let me take the older photograph at first. It has some curl to it because of its age and probably the humidity or lack thereof in this room. I simply place it on the platen, and then you might want to put a nice gentle weight on here. Do we have a gentle weight nearby? No, I guess not. Maybe my hand is the gentle weight, because that is a floating subject. I then come over to the computer, and In this case, as I mentioned to Jeff, I'm going to go to a standalone scanner software. Now there's two types. We would be working with either a plug-in, which works within an application like Adobe's Photoshop, or for instance, PhotoStyler from Aldus, in other words on the IBM world or on the Apple world, and then we acquire that scanner activity directly from that application. In this case, now I've opened it up and I'm using a piece of software called oPhoto. And this is a very powerful piece of software in terms of calibrating your scan input to your output. For demonstration purposes today, I'm not going to go into all these because there's simply not enough hours there to look at them, and we can start with just the Apple Color display as what we're calibrating to. In this case, just like Jeffrey did, I'm going to do a pre-scan, and I should soon start to see an image scrolling down on my screen. This is an important consideration. First of all, are we scanning the right photograph? Secondly, where do we want to do the cropping? Okay. The image is starting to scan down. This is an auto feature, and at this point I have it set for color, so it's seeing this as a color image, even though, as you can see, we're only working with a grayscale image. I'm able to bring this image in as a preview and then do my cropping from here. It's actually a very simple procedure and very similar in different pieces of software, although the control in the software is different. In this case, I will go and crop to the significant image area only. Just takes a little careful eye-hand coordination to do it, and a little luck too. Actually, it's actually very easy to do. And then I can go ahead and prepare my scan. Now this will scan for the resolution of my display device. I have the ability to go in and look at different magnifications, etc., but I know that this is going to work well for the situation that I'm trying to demonstrate right now. So simply, all I do at this point is hit scan. And now it's going out and it's acquiring the high resolution scan to bring into the personal computer. Now, with a standalone piece of software, you have the advantages in many cases of more control over your scanning, but you don't have the advantage of moving images directly into your image processing program. So in this particular case, I feel like my hand is stuck on the scanner because of the curled photograph. As soon as this is done, I'll take my hand away and I'll save it out as a standard file format. It's now doing some sharpening automatically. Most scanners do, and this is an attribute. In many cases, the scanners will permit you to do the level of sharpening that you would like. In this case, I'm going to call it Soldier. Save it out to the desktop. I'm going to save it as a TIFF file. I'm not going to protect it. And then move it out. Now, as I'm saving this out to the hard disk, I'm thinking about a couple things. What's it going to look like in my image processing program? And also, I always want to be thinking about backing up my image. In other words, saving it out to a form of media that I can go back and work on it again and again. Here you can see the Soldier file. I'll now go in and launch Adobe's Photoshop, in this case Adobe's Photoshop 2.5. And as I launch it, I'm able to come in and take a look at the image. Now, as you'll hear Jeff, myself, and probably a number of people next week and the following week talk about, we essentially do most of our evaluations not on a visual basis, but we do it on a basis of using the densitometer there. We want to make sure we have the right percentage of blacks, dark grays or quarter tones, midtones, three-quarter tones, and highlights. And in this case, I will go in and make my evaluation on this image based on those values. So at this point, I'm satisfied with it. We'll talk more about image evaluation and densitometry in just a few minutes. I'd also like to show you another form of scanning, which would be, for instance, from this Polaroid scanner. The Polaroid scanner is really designed to do small images, like, for instance, the Type 50 series images that you might be using in the studio, or wallet-sized photographs. And does anyone have a wallet-sized photograph out there? Thanks, Tony. Tony, come through again. This will be another promotion for you. You realize that.
Thank you very much.
Okay.
Appreciate it.
Well, okay. Keep your fingers crossed on that promotion. We'll talk later. All right. I'm now going to place that into the scanner. And the first thing you do, a preview. A preview will let me go in, take a look at the image, where it is. This does all its image processing on board. I'm now able to come out, select the image that I'm looking for. I'd like to capture this in grayscale at 250 dots per inch, or as I prefer, pixels per inch, and then do my scan. This is a very fast scanner. It will scan up to 500 pixels per inch. And as you can see right now, I've brought the image in. Is it exactly the way I want? No, I'm probably going to adjust the brightness a little bit on this in Adobe's Photoshop or Color Studio or Painter or one of the other image processing programs out there today. It's as simple as that. And Tony, here's your photograph back, because I know you'll be chasing me later if I don't give it to you. Okay. Last, I want to speak today about the idea of working with not a linear array scanner or a PMT scanner, but working with a scanner that uses an area array. This scanner is from Eastman Kodak Company, called the scanner, it's the 2035 Rapid Film Scanner. In this case, I neglected to put on my white gloves, or you'll have to trust me that I cleaned it with an anti-static cloth before this broadcast, but I do have my trusty dust away, or whatever this stuff is, so I can dust away my image. I'll close this application and slide this into the scanner. Now this is a very fast scanner in the fact that it uses an area array as opposed to a linear array. And I'm going to come out, close the current application that I'm in, and launch Adobe's Photoshop 2.1, where I have the driver for this scanner right now. Again, this is not a standalone application, this is a plug-in application. Doesn't necessarily mean a weakness in it, it just generally means a different interface, sometimes not as many controls. In this case, as many controls. I now can come down in Adobe's Photoshop to the Acquire menu, down to Kodak Rapid Film Scanner, and I get an interface. At this point, I have an ability to see what the image is out there. Of course, there's no image scanned yet. Adjust my color complements of cyan, magenta, and yellow. Adjust my brightness, which photographers are calling exposure at the camera end. Now in the computer end, we're going to call brightness, and contrast. View the changes, etc. And I have the ability to look at film profiles. In this case, a positive, negative, generic, or some other film that you might be using. I happen to be using Ektachrome in this case. The resolution will range from a 250 dot per inch low resolution all the way to 2,000 dots per inch. I'm going to scan at 1,000 dots or pixels per inch this afternoon, depending on where you are viewing this. First thing I'll do is focus the image. Now this is usually only necessary when I first install the film emulsion for the first time. After I've done that, I don't have to focus and refocus. It's going through the focusing process, so one-step process. Some scanners permit you to do a visual focus. Believe me, from lots of experience, it's not worth it. The scanner is able to look at brightness changes much more carefully than you can with the naked eye. Now that I have the image in there, I want to put select on. This will let me go through and select different images that are on the sleeve. Oops, went a little far. And that's the image I want. I'm going to stop the focus at this point. And then I'm going to crop into the image. One of the nice things about this interface is it lets me go in and look at highlights and shadow detail right here. So if I want to affect the brightness and then view the changes, I can do so. And now I check my highlights. I'm pleased with that detailed highlight. The shadows are where I want it to be. I'm not basing it on a visual decision. I simply now go in and do the scan of these three individuals. This is a very fast scanner because it's using an area array, doing onboard processing, moving the image directly over to the Macintosh for viewing as we speak. It comes into Adobe's Photoshop, and we now have a picture of the crew having a Coke out on the West Coast, recently on one of our film remotes. So that will give you an overview of the three types of scanning technologies that are very popular today in photographer studios, service bureaus, design studios, and agencies. Now I'd like to go back and speak with Jeff and see where we are on that drum scanner work. Okay.
Well, here's the 3 scans I just completed.
Okay. Now we have the first image of Greg Heisler. Now this was done by Nancy Stewart, one of our faculty members at RIT, and she shoots 2¼ film. Let's go in and take a closer look at that in terms of the resolution. And this is a relatively low resolution file as well, isn't it?
Yes.
2 megabyte file on a 2¼ That's very, very sharp. Okay, and you would sometimes now go in and establish that the highlights were right on the nose and also the shadows in the mustache on Greg's face are correct.
Correct. This is you were speaking earlier. I would come down here and use my show info box.
Okay.
Target an area, and I can go in and actually read the values that I'm showing.
And that's what photographers, artists, and printers should be doing, is
Correct.
not paying attention only to the screen, but looking at those values. Let's take a look at the architectural photograph in the back. All right, now I know this image. It's by Bill Dubois, who is Associate Director of the school, and he's an architectural photographer, has been for many years. Let's take a blow-up of that and see what the resolution is like. Maybe you can close that other file out too. We're going to talk about computer configurations next week, folks, and having enough RAM is really important. The more, the better. So with the drum scanner in this case, we're able to now go in and establish very good tonal relationships in the shadows and in the highlights. And you're going to set your brightness levels for those bright highlights that he has back here, as well as the shadows, correct?
Correct.
All right.
I would do that under Image. I'd go to Adjust, and then to Levels.
Right.
Then with these tools here, it allows me to set a highlight and a shadow dot.
Right. So you're able to go in and make those adjustments? Oh, you're now setting it for pre-press output.
Yes.
Yes.
I've set it up, say if I was going off to a web press.
So if Professor Dubois at this point wanted to go out to coded stock, this is what you'd be doing in terms of setting his highlight point.
Correct.
All right. How about the shadows? All right. And you're setting a 93%, 85%, 83%, and 71%, as you see down the lower right-hand side of your screen. So then we are clipping to the output specifications of coded stock.
Correct.
Right? At swap standards. Good. Great. Let's take one last look at this still life photograph before we get going here. Now this is by Dave Milburn, who is a printing student and previously a commercial photographer in Atlanta and Southern California, as well as others, and he's provided us with a transparency. Let's take a look at that image. Now this is where I think the beauty of a drum scanner comes in, especially in terms of studio photography in large this is a 4x5 film.
And I only scanned it
at 4,000 pixels per inch. What size would the file be?
Be roughly a gigabyte, 960 megabytes.
Well, we won't try that today.
Not today.
Okay. No, not on this show. But you are, in this case, it's just a little bit less than 2 megabytes. You have the ability to optically pick the different resolution, go in and set your shadow point, your highlight point, set your sharpness, and then you're set to go once you set your highlight point and shadow point for your pre-press conditions, right?
Correct.
Jeff, thanks very much. This is great. I'll be back a little while later on with some of my transparencies so you can scan them.
Okay.
Great. All right, let's talk about scanner resolution. What is scanner resolution? Well, it breaks down into a few different important categories. First of all, the spatial resolution. This is the number of pixels per inch. This is the actual space that we assign to any particular area. With scanners, it can be fixed, variable, or interpolated. Know which it is for the device that you're currently working for. We also have to look at the brightness resolution. These are the values, the brightness values that we assign in the shadows, middle tones, and highlights. All scanners do not perform the same. All specification sheets may, but scanners in reality vary quite a bit in that respect. We have to look at the optics too, and I could go into a much greater detail of how optics are used in scanning and how definition is determined. But take it from me on the very surface at this point that the quality of the optics that is used in a scanner is a very significant issue. The signal to noise as well. Do we have a high signal to noise? If we do, that's fine. If we don't, we are usually going to find significant noise in the toe or the low end section of the image. All right. Now, I want to talk to you a little bit about spatial resolution, go over to the computer, and in doing this, I'm now going to open up some files and show you the differences. Now this is a very, what you might call exaggerated example, but I think it will get the point across. And that's the important thing, is getting the point across to you right now. A lot of people are in the fog about this. All right, in Rochester we have a lot of fog, so I know what I'm talking about. Okay, here we're looking at 72 pixels per inch on this particular image. If I was to open up an image that had half that resolution, we would be looking at 36 pixels per inch. And see if you can tell with the eye on the screen any difference between those two images. By the time we go out on the satellite and show it back on your sets, you may not see a real large difference, but it is there. Now let's go in and look at half of the resolution again at 18 pixels per inch. See if you can see the difference now. Now look carefully, because you are going to be tested on this at the end of this session. Okay, I'm only kidding. Although somebody out there might try that. And now I'm going out to 9 pixels per inch. So spatial resolution, or the number of pixels that are assigned to any particular picture area, is very, very critical. All right, and that gives us an idea on spatial resolution. Now let's open up an image and look at brightness resolution. Now I'm going to use a grayscale image to get across the point rather quickly. But if you'll take a look with me here for a moment, and I'll blow the image up so you can see it a little clearer this time, I'm going to go in using the map, assign different posterization levels, which will let me go from its current 256 levels of gray down to 128 levels of gray. That would be going from an 8-bit resolution, or 256 levels of brightness, down to 128. Can you see the difference? In many cases you can't. You'd be surprised if you could in many cases, because there's a good question as we can even see over 200 levels of brightness. Now I'll cut it down to 64 levels of brightness. Some of you may have noticed a shift at that point. I'll switch it back for you so you can take a look. Now I'll go back to 64 again. Notice the difference? I could. Hope you could too. Now down to 32 levels of brightness. You can start to see that there is some banding taking place on the image right now where we're seeing brightness levels break down. For many pictorial applications though, this is still acceptable. And some of your scanners will actually truncate, or should I say, reduce it to this number of brightness levels unintentionally. Now we're down at 16 levels of brightness, 8 levels of brightness, and you can see severe posterization taking place right now. And of course, if I go down even further, we're now down at 2 bits or 4 levels of brightness, or as I go down to 1 bit, we are down to 2 brightness levels, we're down to a 1-bit image, or strictly black and white, line art. Okay? All right. Now, let's talk a little bit more about software. First of all, standalone proprietary software has its advantages that we've already talked about. Do you get it as a Photoshop or Color Studio plugin? Yes, you can. You can also get standalone software. The plugins are very easy to use, convenient, and in many cases are shipped with the scanner and software. The control features that are critical are preview, which we've already clearly demonstrated. The ability to adjust brightness and contrast. Photographers out there, get out of the idea of adjusting exposure. You do that in the camera. In the computer, we are adjusting brightness. adjusting and setting your black point. Your Better Scanner software will permit you to do this. And setting your white point. Setting the resolution is also critical. Not setting it to too much resolution or too little, but setting it to the resolution necessary for your output device. How good is your scanner at seeing the color and interpreting the color? We call this the LUTs, the LUTs, or lookup tables. Does the scanner software have a densitometer built into it so that you can look at your different brightness levels? It's critical. And you must be able to crop. If you don't, you will have massive files and have to only work with the full scanning area. This is a major disadvantage. Does your software or your hardware or both permit sharpening? That is a very important issue. You should also have some control over that sharpening. So if you have the ability to turn it off. Continuous tone or halftone imaging. Let's get over now to looking at the ability to set, okay, we're going to go over now and talk a little bit more about output resolution. I lost my place there for a moment, forgive me. Now, when you're talking about output resolution, for continuous tone output, we generally want to have a 1-to-1 relationship. That's not difficult to understand. What that means is that for every spot or dot that we have out in our output end, we need 1 pixel at our input end. So let's take a look at that now in this drawing. If I have a image size here, I want to enlarge my image from a 35 millimeter original up to a 5 by 7 inch output, and this output has a resolution of 200 pixels per inch, and my image size is 5 inches, let's say 5 inches along this y-axis right here. At 200 pixels, that would relate right here to being 2,000 pixels of information. The question is, what do I set my scanner resolution at? Well, if it's 1-to-1, we must have 1,000 pixels. So in this case, I have 35 millimeter film. I must set my scanner resolution at 1,000 pixels per inch because I'm going from 1 inch up to 5 inch in this case. I still have 1,000 pixels resolution here. I have 1,000 display pixels at my printer. 1-to-1, remember that for continuous tone. Photographers out there, you're saying, I want more resolution than that. In continuous tone printing, it will not help you. In halftone imaging, we generally go by the Nyquist criterion, which simply states that we should have 2 samples in for every sample out, or in this case 2 on the x-axis and 2 on the y-axis, or 4 pixels for 1 halftone dot. Previously I was talking about spots, now I'm talking about going from pixels to halftone dots. As we go over in this case, if I want my image size to be 5 inches, and I am not in pixel metric but in halftone metric, or in other words, lines per inch. In this case, let's say I'm running at 150 lines per inch. 5 times 150 is going to give me 750 lines. In that case, I'm coming from a 35 millimeter film, and if I'm going 2-to-1, it's not 750 anymore, folks. It's now 1,500. So from 35 millimeter film to this size, I would have to set my resolution at 1,500 pixels per inch. Okay. Output resolution. Continuous tone or halftone. We've just discussed what to use and when to use it. At your service bureau, do you know which is which? Find out. The spots per inch for continuous tone or dots per inch for halftone. Please try to understand that when we talk about dots per inch, we're talking about a halftone dot that's generated on a press or some other kind of halftone printing device. Magnification, as I've just described. If your image size changes from the original to the output, you must either up the resolution or decrease the resolution to accommodate your output needs. Your final image size is also critical. If we are going from a 1 inch by 1.5 inch image to a 1 inch by 1.5 inch image output, the formula would be simple. but when we magnify, we must increase our scanner resolution. Again, for continuous tone, 1:1. For halftone, 2:1, or something less than that. Some of you have seen a Spree magazine, or many of your newspapers and magazines today, which are subsampling down to 1.5 or even less than 1.5 to 1. Some people are really pushing the edge down to 1.2 to 1, and that's very, very close and maybe undersampling, giving you lots of problems. Play it safe, 1.5 to 1 or 2 to 1 for halftone imaging. Okay. Now, another thing we have to be considered about is the white point. Are we establishing the right white point for our output media? This has to be determined through testing and your service bureau or your printer. Of course, your black point as well. It's going to be different for RGB values and CMYK values. Your gray balance, again, in the computer world, based on 8 bits of brightness for red, 8 for green, and 8 for blue, we're using our medium point for 128 as our middle gray area for gray balance. Okay. Now, another thing we have to consider here is in evaluating scanners. What would we look at? What's the task that you're working with? Are you scanning 35mm films? Well, a flatbed scanner is not the way to go. Resolution. We have to know if the scanner has enough resolution for our originals to get to the output that we're working to, whether it's a halftone image or a continuous tone image. We have to look at the brightness resolution of the scanner. Many scanners say that they are working at 24 bits of brightness resolution, and in reality they're working at less than that. The only way to find that out is through testing. Generally, for photographic purposes, we should try to be working within a real 24-bit environments, or 8 bits for red, 8 bits for green, 8 bits for blue, and giving you the full complement of over 16 million colors. We also look at the mechanics of the scanner. The stepper motor. Is there enough vibration going on there that creates for us scanner artifacting? The chassis itself, is it strong enough to resist vibrations and movement? Scanners, in many cases, are not stable devices. They get moved around the newsroom or the studio or the agency or whatever. The electronics in the scanner, is the proper noise protection built into the device? These are things that have to be found out through tests, not through spec sheets. We have to wonder, does the scanner have sharpening? Does it have too much sharpening? Can we control it optically or through software? And the tone reproduction. Tone reproduction is the representation of your image, shadows, middle tones, and highlights, based on the output. Does that scanner fit the need of what you're trying to do? The optics, which I mentioned you as well as earlier, you should not be making up for inadequate optics through doing sharpening through software. It's better to have a good set of optics and apply sharpening where it's necessary. The dynamic range, are we getting the full tonal range? Are we fairly representing the toe or the shadow areas or the shoulder and the highlight areas of our films or our other continuous tone images? The speed of the scanner. Do you put the film in and have a scan in a few seconds or less than a minute, or do you have to leave it alone for 15 or 20 minutes? That's a relative question based on what you're doing. The productivity. We've seen scanners here today that do one image at a time. We've seen Jeff work on a scanner that will do many images at a time. Something to be considering. The artifacting, the signal to noise that I've mentioned to you earlier, is something else to look for. And the software. First of all, is it powerful? Secondly, do you understand it? Is it user-friendly? And can you get the technical support to make the stuff work right? Do you have the right film profiles for your scanner? In other words, does it have the lookup tables for a particular ectochrome or a particular grayscale or other color type film? Does the scanner have auto features as well? Many of the auto features today are polished tools that will actually go in and set your exposure, set your focus, which you can do better there than you can visually, and apply sharpening to the image. And the interface. Can you easily interface it with your personal computer system today, whether it be Macintosh, IBM, or it may be on the Sun system or Silicon Graphics or some other system? The size of the scanner. A lot of people laugh at this and say, what difference does the size mean? I still have a lot of space on my desk. Well, if many of you go into electronic studios today, you'll notice that in certain cases, scanners, other pieces of equipment are piled 2 or 3 things high because they've run out of space. for these pieces of equipment. And of course, the cost is a relative issue as well. That has to be considered in the jobs that you're doing. Okay. We're going to do a small demo right now, and I think we'll first take a break and then we'll do a demo, because I could use a break at this point. So let's all take a break at this point, and we'll come back and do a demonstration in just a minute. Everybody take a stretch. Ready? All right. Okay. Now, after we've been scanning all these images, we have to think about image storage. What do you do with them? You get the images into the computer, you have to put them someplace, especially when you're finished for the day. Okay? First of all, there's two basic areas that we're working with in image storage. I'll talk about read-write storage at first. The most common way would be to record images onto a floppy disk drive. A floppy disk can hold between 800 kilobytes and 1.44 megabytes. This, for many purposes, is very inadequate for holding images. It would hold, at best, a video-grade resolution image. The other thing that's become very popular because of the speed is your own personal hard drive. Your own personal hard drive gives you the capability to connect to a personal computer and then store the images in backup. The personal hard drive is something that is physically connected outside of your computer, or maybe inside your computer as well. Some of them now have become quite small. In this case, a 200 megabyte hard drive, some of them are of that size and well over a gigabyte. Removable media. Removable media with photographers and artists has become very, very important. This is the way we sneakernet. Sneakernet means we're moving the images between our studios and our service bureaus, where we either get our scans or we're going to a place to output our scans. Sneakernet, in this case, we would be working with a SideQuest removable, a Bernoulli removable, or possibly even a Ricoh removable. DATs, digital audio tape. In this case, a very nice sized, small mechanism that we can hold anywhere from 2 gigabytes up to 8 gigabytes compressed. In this case, I'm using a Micronet 8 gigabyte hard drive right here to do my backups from Jeffrey's scans early on. Very good way of backing up your information. Not used really for active image manipulation, just to back up your files. In addition to that, very popular in the color separators world is the exabyte tape system, which will hold also up to 8 gigabytes of space. And of increasing importance to us is the use of your magneto-optical, MOs as they're referred to. The magneto-optical are read-write mechanisms that today will hold anywhere from 128 megabytes to over a gigabyte. This is the new 3.5-inch size that will essentially fit right into your pocket. And you can just record a lot of information in there, a lot of pictures, a lot of pages on one particular disk. Your Floptical, which I don't have here today, is about the same size, but would be floppy media, still using the same sort of read-write magneto-optical technology, but could hold up to 25 megabytes. First coming out on the PC platform and now on the Macintosh platform. You have to also consider the CD-ROM. Read-only memory storage has been out for some time, and we have CD-ROM XA and the evolution of photo CD, which we're going to be talking about in a few minutes. CD-ROM holds a tremendous amount of information in a very efficient fashion. The new CD-ROM XA, standing for Extended Architecture, is able to hold Kodak's new photo CD format, and we'll talk a lot more about that in just a couple minutes. And a film recorder. With a film recorder, we're going back to the film itself, 35 millimeter, 4x5 or larger films. Here we have, again, read-only technology, but a good way of storing images. A drum-based film recorder like a light valve technology will get up to even higher resolutions of many thousands of pixels per inch, and going out to as large as 16 by 20-inch films. We're going to talk more about these hard copy output devices in the next 2 weeks. We also have electronic prints like we have here with the photo CD. The photo CD has an index print in it, which is a thermal dye transfer print. This is one of some popular print technologies today. In this case, a very photographic looking quality image. And we have laser disc, an analog technology, but capable of keeping large areas or large quantities of images on here, on both sides of this particular disc. We don't have the drives here for that today. All right. Well, when we look at image storage, we have to consider the uses of these devices. As I've mentioned, tape drives are used for backup. Hard disks, like we had talked about before, in this case, working with a hard disk that would be part of a hard disk mechanism, is for ready access of images, are built into our computers already, or we are using a separate standalone drive. The reliability of the system. Some of the systems out there today are not too reliable, especially if you're moving from one area to another. Find a media that works well for you in that environment, and then you've got reliable media. If you're moving outside of that environment to new service bureaus using new kinds of software, expect there might be some reliability problems. Access speed. How fast can we get the information off this disk? That's a critical issue as well as the compatibility of these systems. Will your software from one type of hard disk or storage utility work with another similar piece of hardware that's supposed to read that? Compatibility is a critical issue today. And the cost per megabyte. The cost per megabyte can be very, very high on hard disks to very, very low, for instance, on Kodak's photo CD. Okay, at this point, when we think about storage, it brings up the topic of photo CD. As I've mentioned in our announcement about this teleconference, we're going to put a major focus on that today. And I'm delighted today to have with me Paul Melnichuk from Eastman Kodak Company. Paul Melnichuk is from Los Angeles, just recently moved there. He is the manager of technical development for CD imaging at Eastman Kodak Company. You have to consider Paul comes from a whole development area in imaging and computers and compression and file formats, and he was one of the co-inventors of photo CD on the team since 1989. And I'm delighted to have you here today, Paul. I'd like to give you some questions, and thanks for joining us. Paul, can you tell us, how did the whole concept of photo CD come about in the first place?
Well, we saw an emergence of various technologies, Doug, starting with the ability to scan at rapid speed, the increasingly lower cost of memory, computer memory, faster computers, and the enormous popularity of the compact disc in the music and audio world. What I'm going to do is actually use this disc as a means of helping us in our conversation today. What we saw was the opportunity to merge these together and enable an individual user to both store and also distribute images in a common format, namely the compact disc.
Well, when you think of photo CD and how it's currently seen by many people out in the public, they see it primarily as a consumer-driven product or a consumer product. I now see it's going towards professional imaging as of equal, if not greater, importance.
Absolutely, and what's very exciting is sitting here and listening you describe all of these various products between scanners and desktop image editing and also storage options. Photo CD really is more of a concept of which the first manifestation that was developed back in the first part of 1990 is the ability for an individual consumer to record images onto the photo CD or compact disc. However, the concept really is more general than that, and that is the ability to record images in a digital form onto a common distribution format like the compact disc, for the ability to copy these, give them to a friend, to a colleague, and being able to store these in a very convenient and low-cost fashion.
Could you give us a description of how the photo CD system works, Paul?
Certainly. I'm going to use this photo CD that I just popped into the photo CD player here.
So you're giving the demonstration from photo CD right now?
Right. I'm going to use this as my vehicle. And since we're somewhat unstructured here, what I'll do is I'll use the random access capability of the photo CD disc and the player to allow me to just jump around to whatever image I choose. So again, just to reiterate, we've mentioned that photo CD as a concept allows an individual to take his roll of film, let's say, that was initially captured on a 35mm camera and perhaps even large format, as we'll get into in a moment, and be able to record these images onto the compact disc at a fairly affordable price. And part of this capability is in the imaging workstation that we offer through Eastman Kodak called the PIW. This is the equipment that a consumer-oriented photo finisher or a professional lab would acquire in order to create these discs.
Mm-hmm. Now this imaging workstation would be located primarily at photo finishers and customer professional labs.
Right. And what we're seeing right now is an emergence of cooperation between the pro labs and the pre-press separators, where they're working together to try to enable photo CD to work in the pre-press world.
So we're seeing some migration not only from the pro labs but over into the pre-press world. Are there other places where photo CD is starting to spring into that would not be, let's say, in traditional publishing or photo finishing?
Well, one of the most exciting areas right now is in multimedia, and we're seeing the emergence of still images as well as other types of graphics and text and audio as well. So there are lots of applications, medical, and we'll get into that in a few minutes.
Great.
I'll be happy to share with you some of those details. But first, let's back up a little bit and talk about the format of photo CD, because this is really the blueprint and the fundamental architecture of this system. I'd like to refer you to the slide that I have up here. You've mentioned before scanning, as you've discussed some of these other scanners here. Just to put this in the context of photo CD, in its first manifestation again, what I call the plain vanilla photo CD system, we are scanning 35mm negative and reversal film, both color and black and white, with a scanning resolution of 2K by 3K. In terms of the nomenclature...
2K by 3K?
A number of pixels.
Okay.
So referring to the diagram here, that would be 2,048 lines by 3,072 pixels across.
Right.
We feel that that adequately captures the photographic content of the 35mm format. Putting that into the terms that you used earlier, that would relate to approximately a 2,000 pixel per inch scan off the 35mm film. Once we have that scan, we then apply several processes. The first and most important would be in capturing this red, green, and blue RGB scan, which is now an 18 megabyte file. We transform this into another color space, which we call photo YCC. YCC referring to the luminance and two chrominance channels for the representation of the color of that scene. Once we've captured it there, and incidentally we do so for two reasons. Number one, it's television ready. It's in a format that's consistent with the representation of signals as they are broadcast and also sent from a VCR, let's say, to a consumer television. And secondly, because it affords us about a factor of 2 in compression. So there are two very important reasons. Of course, once we're in YCC, we can go into other color spaces, like back into RGB for a monitor, also into CMYK for printing, and other types of spaces as they are appropriate. Once we have the data, this color data, we then go through some extensive density exposure and color correction on a scene-by-scene and film-by-film basis. After that, we then compress the data down to about a 4.5 megabyte per image file size. Now, just a word on compression, and this is, again, a key component to our format, is the idea that we are recording in a hierarchy, and this hierarchy allows a user to access that resolution which is required for the particular application. And again, referring to a diagram here, what I've outlined here are several resolutions which comprise the photo CD image pack format. This would be a format that's recorded for each image on the photo CD disc, and they include a thumbnail, which we call base over 16 or TV over 16, up to and including a TV resolution, which is the resolution that you're seeing on your monitor currently, up to and including a 4-base or 4 TV. This would be 4 times the resolution of the base image as it's displayed on the TV. If and when HDTV becomes a standard, we would of course support that with a HDTV model photo CD player, and would allow an individual to view images of full HDTV resolution. So these discs contain much more information than a consumer may use, let's say, on a television viewing, but would be able to use them in the future. The highest resolution for 35mm photography would be the 16 base, or the 16 times the resolution of the TV image, and that would comprise the standard plain vanilla photo CD image pack, which we call a photo CD master.
When a person gets an image on a photo CD master, they're getting all those, though. They don't have to specify.
Absolutely.
They get them all.
Yes.
So what I'm hearing from you right now is they're getting everything from very low resolution images that might be used just for search to high resolution images that might actually be used for publishing. So, and now you're telling me that it's also could be used for HDTV down the road and for other publishing applications. It sounds future-proof, in a sense.
That's what we try to do. Again, with the file format being the blueprint or architecture of the entire system, you have to kind of think of everything ahead of time, and then with a standard like the photo CD file format, once you've established it, it's really hard to change. So we'd like to try to envision all the applications that we can for the future, and incorporate that as part of the format.
One of the things that's really exciting to photographers and artists and people in the publishing industry is some of the new formats that are coming out in photo CD. These are new to all of us, and some of them aren't even available yet. Maybe you could tell us a little bit about them.
Certainly. We announced last August 5 different formats which were spin-offs of the original photo CD master disc, and these include a Pro photo CD format that would include higher resolution scans, namely a 4K by 6K scan, which could be used with a new workstation that we're introducing later this summer that would allow a Pro Lab to offer a 2¼ inch photographer or a 4 by 5 inch film the ability to scan at even higher resolution. So these would be 4K by 6K scans. In addition to the higher resolution, we also have the provisions for some additional capabilities such as watermarking and encryption of images, which could be used to restrict high resolution files, and let's say if a copyright holder would like to do so. So we have a lot of hooks in place for the Pro Photo CD format that would allow a user to take advantage of higher resolution and some of the features that a professional photographer might ask for. Another spin-off to this family of formats is the Portfolio CD, as I mentioned earlier. This would be our entrance into the multimedia type applications where we can incorporate audio and branching so that you now have an interactive type experience with these photo CD discs.
Let me interrupt for a second. Paul, when you say branching, what do you mean?
Branching exploits the random access capability of the compact disc format, and rather than linearly having to go through the disc, what you could do is simply bounce around, like what I've been doing so far this afternoon, and simply skipping from one image to another. Branching would allow a user, through a menu of, let's say, several choices, the ability to hit a button and just jump to that part of the disc. For example, let's say I was a publisher and I wanted to publish a training manual in various languages. Whereas with videotape, I would have to produce various titles, various flavors of the videotape for the different languages. You certainly wouldn't want to put all those languages on one videotape. If you were the unfortunate one to have to skip over to the end of the tape, that could be a bit time-consuming. And you also don't have the precision of getting exactly to that point.
Well, photographers, though, also, when you mention the name portfolio, that rings a big bell. Our eyes open up when we say, portfolio. That has some interesting possibilities there in terms of actually designing the presentation of our work, correct? We can't do it yet because it's not available yet, but this is coming.
With Portfolio, what we envision is the multimedia or portfolio author, the ability to import photo CD images, graphics that may be generated from your favorite graphics or presentation program on your desktop computer, as well as audio that may be derived from an audio cassette or a DAT tape through professional means. And again, referring to the diagram here, this is the concept that we envision for portfolio authoring, is the ability to import these various assets into the desktop, and we will be offering this solution for authoring later this summer. This will be achieved through a workstation, and you can go to your service bureau or Pro Lab that would offer this capability to do this kind of authoring. We've developed in connection with this a scripting language that would allow a desktop user to create a script, essentially all of the information necessary to construct the branching schemes for the disk that would all reside on a floppy disk. So now you bring to your service provider a photo CD image containing your images, let's say a floppy disk containing some of your graphics, and then of course your audio cassette. Bring all these assets in with a script on the floppy disk and say, make me a portfolio disk. And this is a service that will be enabled later this summer.
Paul, one final question, real short. Can you tell me, where do you see photo CD at the end of this decade?
I think the exciting thing here is that we've got the emergence of information, in this information age. We've got word processing, we've got digital audio capabilities which allow a user now to record an entire album in one's bedroom. And now we've got the introduction of images, digital images into the desktop, and also being able to display them on a low-cost consumer device like our photo CD player. This is an exciting time as we have individuals now able to bring all of these various assets together and allow for the personal expression of words, of audio or music, and now of images.
Thanks a lot.
Thank you,
We'll look
Doug.
for more for photo CD. And in fact, speaking of photo CD, I'm going to come over right now and show you a few things, or show the audience a few things about photo CD from Digix.
Great. Thanks, Doug.
Also looking forward to getting some of this water. Speaking of photo CD, in terms of publishing images, I'm going to take out Paul's disc right now, and I'm going to put in a disc from the Smithsonian. I'm using Kodak's photo CD player. This has no connections to a computer, but essentially I thought you might like to take a quick look at some images from the inauguration. In this case, it's a disc produced by Digix Imaging in Washington, D.C., and it's produced by the Smithsonian Institution by their photographers. And they have some special images here in terms of looking at the inauguration. This is really a storybook of what happened during that 24 hours, and it's available through Digix. So I just think I'll show you a couple quick images here. And you can see how we can take these images in quickly, edit them from a number of photographers for display. So there are people out there using this now from a publishing standpoint. Okay, that's one way of looking at images. And I'll put this on play while I'm going over to the other side. The other form is to come in through a CD-ROM XA. I had the very good fortune through John Larish to have loan of images on photo CD from photographer Tony Spina. Tony Spina from the Detroit Free Press. Some of his fantastic work, his photojournalism, is available to us on photo CD for this particular presentation. Now, like Paul said, I'm leaving the video domain and I'm going out to a publishing or higher end domain at this point in terms of quality images. I'm opening up Adobe's Photoshop. In Adobe's Photoshop, I have the ability to come into Acquire and then go out and look for the Photo CD Access software. In this particular case, I'm able to go out and look for images from Tony's. And he has some fantastic images here, and I want to give you an idea of what the resolution was like. In this particular software, I'm able to go in and do my cropping and select the resolution, as Paul had mentioned, anything from 1/16 base up to base, which would be video, or base 16, which would be 16 times the video information. And I thought it would be interesting to bring in a base 4 image. I'll do a full image here of Mother Teresa done by Tony Spina. At this point, I can also make some corrections in terms of brightness, color, red, green, and blue, and also the saturation. There's a lot more information than we could be discussing here today, but for time purposes, I'm going to bring this in and just show you the quality. Now, this is going to be an image that's roughly 1,000 by 1,500 pixels. It's now being brought into Adobe's Photoshop from the photo CD image. And after we do that, we cannot write back to the photo CD, but we have the ability to work on the images in there and then save them out to some other form of temporary or permanent storage. In this case, most of the time we would be using SideQuest removables here at RIT, although a lot of people are now starting to work with magneto-opticals, which are holding quite a bit more information. The SideQuest removables and Bernoullis and other forms of portable storage are also starting to increase in their capacity these days to 80 and over 100 megabytes, depending on the mechanism that you purchase. So here comes Tony's image right now. It's in 24-bit color. I'm going to go in here and rotate it 90 degrees counterclockwise so we can look at it in the proper rendering. And you have to realize that I'm working with an image now that is very capable of high quality output, far above video, and also high quality halftone output. So we're now bringing the image up. And we're ready to do the work. I'll now bring us out to a scrollless screen without the sidebars on it, and you can get an idea of the quality of this image. You have to realize there are other images on here that have 4 times this much resolution. As I mentioned to Paul earlier, it's the same, you get all of those files each time. So for publishing, for photographers, for archiving images, and also for saving memories, as you've heard, it's a very, very powerful tool. I think we're looking just at the beginnings of the potential of photo CD today. We have a lot to look forward to. At this point, I'd like to show you some tape that we've done out in the West Coast, and a few individuals that have some things to say about photo CD. So let's take a look at that tape right now.
Zizix. Zizix is it's the digital division of A&I Color. And A&I Color is a major film processing lab here in Hollywood. We do professional E6 processing. We're the only Kodachrome processing lab west of Texas. And so our clientele is mainly professional photographers. And so Zizix is the digital part of A&I. We've also chosen a particular path, and that is to service the professional photographer specifically. We did not go after the advertising agencies and the movie studios. We didn't go after the high end of the market. We went into things that professional photographers, individual photographers can use. Photo CD was a major part of our strategy because it's very affordable, and because the things that Photo CD can do are things that photographers need. It provides people with inexpensive ways to get into the digital arena, and for a photographer, that's very important. The biggest concern that photographers have about digital imaging in general, and photo CD specifically, is losing control of their images. It looks so beautiful up on the screen that they immediately think, well, these can be stolen, nobody will pay me for these images, or they'll pay me very little for these images. There's a lot of schemes out there that are involved with giving people only a thumbnail view so that they can't actually use them, and having to pay for a high-res view. It's a big issue of how people are going to deal with the rights of photographers. The other thing, of course, is that if you deliver a digital version of something, it can be changed very easily. What photographers don't understand is that right now, when they deliver someone their work, they give them a very high-quality dupe, or they give them a very high-quality print. Well, those can be easily digitized. And if you give me a high-quality dupe, I can make a poster out of it without any problem at all. So it's really a problem of perception. It's something new, it's scary. And I would say the other thing about Photo CD that's interesting from our point of view is that about 80% of my clients that are using Photo CD right now are people who were not doing digital imaging before Photo CD came along. It's an enabling technology. It's a way to get into the digital marketplace in a way that people could never afford to do before. And I think that in the conversations you're having with other people, you're going to find that that's exactly the case. This opened the door.
Patrick Media Group is an outdoor advertising company, and what that is that's billboards all across the nation. We have about 18 offices all across the nation, and we do outdoor advertising. What we did, we took all of our library from the middle of 1986 and scanned all the images that we've done in Southern California. We got close to 8,000 images on CD, and that equates to about 80 CDs worth of images. So that when an account executive with our company wants to wants examples of this, we can very quickly give them a comp or sheet that has examples. So you can take this to a client and give it it's like a leaving piece that they can use. This one's on beverages, but we've got 8 different images that we put on here. Here's one for healthcare. Now, I've taken these in Photoshop, manipulated them, imported them into Kodak's page layout program, which is called Renaissance, and then printed these. And these are printed out on a Xerox 5775 color copier that is connected to my Macintosh via an EFI Fiery system. Now, these pages, if you sent these to a photo lab to have, or to a printer, and had color separations made, and then had them all stripped together, you're talking about somewhere between $300 to $450 to produce that. Each one of these pages is less than $1. So for an account executive, he can afford to leave them somewhere. We can print them out in the hundreds. So the cost savings for us and the ease and flexibility of producing this type of thing has really helped. Looking in the future, we want to take this whole system that we have here in Los Angeles and duplicate it 3 times. All the CDs, the Mac system, the Xerox, the writable CD, and the jukebox that we're going to put all these CDs in. We're going to mirror that in New York and Chicago so that these 3 locations can take care of and support all 18 offices. Eventually, we're thinking way down the road, we can put this on fiber optics so they can call in and access these central locations and download images so they can do it very quickly.
And to look at photo CD and the way things are going, I should say beyond the point of just mom and dad looking at pictures, I think this gives someone that, if I was back at OP or an art director for some other company, it gives me the opportunity to really achieve something on the higher level of a SciTech scan, something a little bit more, because I may not be able to have enough money for a 24-bit scanner. I may not have enough money to do a lot of these things, but yet I'm still wanting to produce a certain level of work. We've talked to people about photo CD, and they say, what's that? Or, it's for grandma and grandpa. We don't think it's going to do anything. So there are some people that I don't think are really with, I think, the mentality where they think where photo CD will be, now or 6 months down the road. It's a big market when you're talking about color scanning. I think there's enough of that market to go around for various different groups of people. Going back to advertising art, for example, they tend to work with one vendor, and they may stick with that one vendor for a long time. And as that new vendor brings in new products and new marketing support items, they might go back to that creative director and say, look, Creative Bob, we have something new we'd like you to try. And that could be a photo CD service, it could be a new scanning service, it could be a number of different things. But I think that's kind of part of the way where the market is going and where that may change in the next few months. Doctors are looking at photo CD and other electronic media scanning packages to include text and client data, and if you want to share that with a colleague in New York, that can happen with a Macintosh, an IBM, or a PC, and a simple modem. So I see some breakthrough areas in medical, I see some breakthrough areas in real estate. I also think corporate communications, I think, would be a big thing that would be opened as well. One of the easiest things to do now is to do 35mm slide presentations to present an idea, a piece of information. It could be a stock report, or just simply, hey, where's the company at right now? Let's see that. Well, the old way is to do 35mm slides and make duplicates and send them to New York or what have you, but that may tag along a person as well. Well, now you can use Revco, Safeway, Kmart, and get that slide presentation duped on a little 3.5-inch gold disc, and for a few bucks, pop it off Federal Express, and they can watch it from a board presentation in New York without having to have somebody there. So I see a lot of these things happening as a result of new breakthroughs in electronic imaging.
Folks, now that we've gone into a considerable part of this program, your questions might be starting to surface, whether that has to do with the desktop scanners, drum scanners, now especially with Photo CD and its recent presentation by Paul Melnichuk. Please phone in your questions or fax in your questions. I would ask, when it comes to fax questions, keep them brief. Unlike the way I would normally do them, keep them brief, and that way we'll be sure to get to them. The numbers are on your screen. Please get in touch with us as soon as you can. Okay, now that we've been looking at acquisition, we've been looking at storage of image, We have to think about working with our service bureau. For many of you out there, the concept of a service bureau is a new one. What is it? It's a service provider, as Paul had mentioned. What does it look like? It can vary from place to place. A service bureau in many cases has been aligned with prepress output, especially for typography and halftones. But in many cases today, some of those lines are blurred between photo finisher and prepress output, where we have some places that are giving us both. In most cases, Service Bureau is giving you some form of input and output services. Where do you find one? That's your assignment. Find one in your area. The larger metropolitan areas would be more easy to find them, especially in the yellow pages when you might look under service bureaus, you might look under typography, you might look under professional labs or photo finishing labs. What kind of people work there? All different kinds of people. Some people who have been out of the photo finishing background and some people who have been out of the prepress background. Please be clear on this. It isn't like one service bureau is giving everything, but in certain service bureaus they give halftone output, in other service bureaus they may give continuous tone output, and some of the newer service bureaus may give both. Who do they service? Well, they're servicing photographers, agencies, they're servicing people who are doing personal publishing. And what they're doing in most cases is getting you to hard copy through films or through a continuous tone print that you might be holding in your hand, that you take out. What are your expectations? That's what your larger assignment is. If you're getting involved with electronic imaging via photo CD and your own personal computer, whether it be the portfolio that's coming down the road or some sort of desktop publishing right now or creative imaging, if you go to your photo lab, they may not have the services that you need. When you go in there, be reasonable with your expectations. They, like you, may be just starting to get into this business. The other thing is, you have to know what you want to do with these images when you go in there. And to know that, you should have an idea. Are we going out to film? Are we going out to a reflective print, transparency? Or are we going back to a photographic print again? Their expectations of you is to have a pretty clear idea of what that is. And right now, it's a matter of getting to know one another. Now, when it comes to service bureaus, I will place the word on one more thing. Communication is the critical issue. Communication. Get in and get to know these people. Have them find out what you're doing with electronic images, whether they be film-based or art-based or some other kind of input-based. Find out what their output services are as well, and how you should prepare your digital files to optimize on their output systems. 2 reasons. You want quality, you want what you want, and secondly, if you don't, they will charge you money to make those images look right. So you will save yourself money by learning how to communicate well. It's time to go over to Q&A, questions and answers. And the phones are open. I have David from Michigan. David, you out there? Okay, David from Michigan, are you still there? Hello? All right. Looks like David's patience ran out, or he didn't take a break before and he needed one now. Clifford from Wisconsin.
Hi.
Hi, Clifford.
This is Cliff Carroll from Milwaukee. I've got a 2-part question dealing with resolution.
Yes.
We're planning on doing some color scanning of color photographs to be imported into some type of a design program such as Arts and Letters and eventually sent out to a printer to produce color brochures. First part, is there any difference between scanning in a large original and then reducing it down in size to a smaller output, or starting with a smaller original and going to a larger output? And the second part is, you've talked a lot about dots per inch in scanning, but my scanner actually works in lines per inch. Mm-hmm. What is the relationship, if any, between dots per inch and lines per inch as far as output quality?
Not seeing your scanner, Cliff, it's difficult for me to say, but when it does say lines per inch, does it give you certain settings that you can select, like 300, 600, 1200?
Yes, we can go to anything from a small amount, 50 lines per inch, all the way up to whatever you want. We've been scanning primarily in the neighborhood of between 100 to 150 lines per inch.
What type of scanner are you using?
It's a pass-through type scanner. It's called a Moose Tech.
Okay, I've never heard of that scanner before. There's a lot of scanners that I haven't heard of before. If it's a pass-through scanner, it sounds like it might be a sheet-fed device. Does it take sheets of paper, like, for instance, type paper? A sheet-fed?
Yes, that's what it is.
Okay, that's a sheet-fed scanning device that may or may not be suitable for what you're trying to do. Getting back to your original question, if you can start with a higher quality original and scan, you're better than to start with a smaller quality original and scan. So that is where you would be. In many cases, some scanners will call the pixel rate either dots per inch or lines per inch. But it sometimes can be confused with lines per inch in terms of halftone output. So you'll have to clarify that, and the best way to do it is through your manufacturer and your owner's manual. I'm telling you that because I don't know the answer, not knowing your device. Thanks very much. Jim Utter from Santa Ana, California.
Yes, how are you?
Hi.
My question relates to removing artifacts that are created by scanning materials that are already in halftone format. In other words, do moire patterns result from that, and can you get rid of them?
From scanning halftones?
Yes.
Yes, you can create a moire from that, although a lot of software today is fairly smart and will permit you to remove that through their scanning software technology. So in other words, it will say remove halftone screening, and the way it's set up is to sample it as such that it will reduce, I don't want to say it would totally remove, but reduce moire considerably. If you don't have that in your software, one of the things that separators like to do and service providers is to take the original on the flatbed scanner and make slight shifts like this. Let's say at around 2 or 3 degrees at a time until they find the most acceptable and least the least problems there. Give that a try. I think it'll work for you.
Thank you very much.
Sure thing. Kathy Collins, an old friend.
Yes.
Hi, how are you, Kathy?
Hi, Doug. I'm actually taking advantage of asking someone else's question in the audience at RIT so I could say hello to you.
Well, I'm delighted to have you as an interpreter.
The question is it possible to store Kodak DCS 200 images on photo CD?
At this point, I don't think it's possible, Paul. Is it?
But we're going to allow that.
Okay.
Enabled later this summer.
Later this summer, Kathy, I just got some real-time expert advice from Paul. Later this summer, we will be able to save DCS images right out to photo CD. Yes.
Great. Thanks, Doug.
Yeah. Hope I see you soon.
Yeah, bye-bye.
Bye-bye. Mike Turpin. Getting back to that question, that's going to be the portfolio format. By the way, before I get to the next question, Mike, would you hold with us just a minute? If you have any questions on photo CD or any other Kodak products, call 1-800-242-2424. Okay? All right. I want to repeat it one more time. That's 1-800-242-2424. From the people in the audience, I better do it a third time. 1-800-242-2424. Okay, Mike, what's your question? Mike from Indiana.
Yes, hi, I'm calling from Columbus,
Okay.
Ivy Tech in Indiana. How far away is the right readable CD system, and how close is it to the general consumer use?
Mike, the right readable CD system is available right now. I know of at least 2 manufacturers that are producing it. Eastman Kodak Company, for one, is producing it. But the major problem has been the affordability of these systems, and now they're coming down below $5,000. You have to realize this will not be writing photo CD format, but will be writing in CD-ROM format. So they are out there right now. Check your weekly news magazines. In this business, it doesn't happen in the quarter, it doesn't happen in the month, it happens in the week. Okay, so check your weekly magazines. Miguel from New York.
Yes, how are you?
Hello?
Hello?
Okay, I hear you now.
Okay, great. I have a question pertaining to CD resolution. I needed to have it explained to me in photographic terms. suppose at the highest resolution on a CD, I was to make a print, let's say 30 by 40. How sharp would that be?
How sharp would it be?
Yes.
It would depend.
Would it be acceptable for let's say, posters and things like that?
I have seen images that have been printed out to larger than that from photo CD with no distinguishing differences between that and film. Now that was a very specialized system. You would need to have, you would have enough resolution with a photo CD to make very high quality prints. Would it compare to some of the higher resolution 35 millimeter films? Probably not, but it would be very, very close.
So I will have to wait then before I start putting all of my photographs into the CD, right?
I would say there's a couple things for you to think about here, and that would be Pro Photo CD would be your solution in that sense. If you want more resolution, it's just hurry up and wait a little while. It won't be here.
Okay,
it will be here very
thank
soon.
you very much.
That's your best response. Good luck with it. Okay. Okay. All right. Now I'd like to review very closely. That's all we have time. We have questions for. If some of you didn't get your questions in, you want to fax them in, we'll try to get to them next week. This week we've hit on a number of key issues. That is bringing your images into the computer. Electronic cameras is a very small, minuscule way that we capture images today. Very few images are done with electronic cameras. The reason for that is the cost and the quality and the fact that they are usually only necessary in specialized situations. Scanners are the way we're moving images into our computers today. Get to know scanners. Get to know them from hands-on experience, not by what you read and not by what you hear. Storage is another important consideration. If you get the picture into the computer, what are you going to do with it? Are you just going to get it in, look at it, manipulate, and that's it? No, you have to bring it in, work on it, and then store it. Look at the different storage media that we discussed today, the attributes, the problems, and the cost per megabyte that's necessary for different storage technologies. They will become better and less expensive, even though right today the cost per megabyte is very reasonable. Output technologies, as we'll talk about a lot more in 2 weeks, is another important issue, especially to photographers and artists who are looking for a high quality output. Well, there is high quality output today, and there are some services, there are some forms that are output there that go beyond what you can even do with photographic materials. They don't replace photographic materials, they essentially enhance what we have. You must discover this through your service provider, and I would suggest a local service provider at this point because you learn from him or her and they learn from you. And your service bureau. Communication is the issue. They are not all cut out of the same mold. Go in ready to ask questions, ready to learn. Okay, that's it for this week. In terms of scanners, next week we're going to be dealing with the electronic darkroom. Thank you very much for joining us for this second part of the Electronic Still Photography Series 1993. Thank you to our guest Jeff Schufelt working on the drum scanner, Paul Melnichuk from Eastman Kodak Company, and of course Tony Girardi, my floor manager. Thank you very much. Look forward to seeing you next week, where we'll show you how to set up your own electronic darkroom. See you then.